We're now going to look at general vector problems. These are questions where you're given a vector diagram and you're given some vectors in terms of a lowercase letter, and your job is to get the other vectors in terms of the same lowercase letters. In this particular question, it says that G is a point on the line FA produced. Now, FA produced means the line joining F to A is extended at point A, and then G is some point on that line. Also in this particular question, we are given a regular hexagon. Regular meaning all 6 sides of the hexagon are the same length. Also, when we break up the regular hexagon by joining opposite corners, we actually divide it up into 6 equilateral triangles. So in other words, all of these lengths that my pencil is currently running over are all exactly the same. Okay. We're also told in the question that the length AG is twice the length FA. So we're now ready to start answering the question. It's going to tell us to work out different vectors in terms of the letters T and V. So let's look at part A. Part A says, let's work out EO. Now, first thing we're going to do is put the arrow direction on the vector. So we're traveling from E to O, so the arrow points at O. Now, in order to get the vector EO, we're going to make it the sum of the vectors between its tail and its nose. So traveling from the tail E to the nose O is the same as going along this vector and then moving along that vector. So we're moving against the arrow, so we need to make this vector negative, and then we're adding on 2V. So EO is just going to be negative 3T plus 2V. And once we've got it, put brackets around it to keep the terms together. Okay, we want to get the vector FA now in terms of T and V. So vector FA is here, and that means the arrow is pointing at A. We're moving from F to A. Now, you could try to make FA the sum of the other vectors between its tail and its nose. So you could say, okay, well FA would be 2V, I'm moving with the arrow, and then I'm adding on this vector, but then you're going to say, well hold on, I don't know what this vector is. Another way you could do it is if you look at the vector FA and you look at the vector EO, you'll notice that they are parallel. You'll notice that they are the same length, and you'll notice that their arrow direction is exactly the same. So that means they are equal vectors. So they're exactly the same. And we have worked out EO in part A, so FA is actually going to be the same. So FA is going to be negative 3T plus 2V. Now you could do it another way. You could do it the first way that I suggested. To get from F to A, that's the same as moving along this vector and along that vector. So it would be 2V, but then O to A, this vector here, is the negative of this vector. Now, why is it the negative? Well, yes, they are parallel. Yes, they are the same length, but you're moving in the opposite direction in each of those vectors. FE, you're going up the ways, OA, you're going down the ways. So OA is the negative of FE. So it would be 2V minus 3T, which is exactly the same as this. Okay, let's get AG. So we want to move from A to G, so we'll put the arrow on first. Now, we can actually use the information in the question to get AG because it says that AG is twice FA. We've already worked out vector FA, so AG is twice FA. So it's just going to be 2 times the vector we got for FA. And then we'll multiply the bracket through by 2, so that's going to give us minus 6T plus 4V. And again, once we have our result here, put brackets around it. Okay. Part D, we want to get the vector DB. So we want to get the vector joining D and B. So we're going to draw it, put it in the diagram. Now, and the arrow points to B because we're travelling from D to B. Okay, so again, we can make this unknown vector the sum of other vectors between its tail and its nose. So going from D to B would be the same as going along this vector and then along that vector. Now, do we know what DC is? Well, DC and FA are equal vectors because they are parallel, they are the same length, and they are going in the same direction. So DB is the same as moving along this vector, which is the same as FA, which is this. So we're going to have minus 3t plus 2v. So that's going to bring us to here. Now, we're now moving along this vector CB. Now, the vector CB and the vector here FE, they are parallel, they are the same length, but you're moving in the opposite direction. This vector here you're moving down the way, whereas this vector here you're moving up the way. So that means that CB is the negative of the vector FE. So we're then subtracting 3t. Okay. So we can tidy it up. So we're going to minus 3t, subtract another 3t is going to give us minus 6t. And then we're just left there with plus 2v. Okay, and that's our answer for DB. Okay, we want to get DE. So we're traveling from D to E. So let's put the arrow on the line to make it a vector. Traveling from D to E. Now, again, there's different ways we could go about it, but probably the easiest way to do this is to recognize that, well, if you look at the vector DE and you look at the vector FO, they are parallel, they are the same length, however, they are going in opposite directions, so you have to make vector DE the negative of vector FO, so it's going to be minus 2v. So that's the most straightforward way of getting vector DE. Don't get me wrong, you could say, well, going from D to E is the same as going from D to O. So this vector here would be the negative of that vector, so it would be minus 3t. And then you would be moving along this vector here, EO, which you would have worked out at the start. But you're moving in the opposite direction, so you would have to make that negative. So you would have minus 3t, subtract this bracket, so the t's would cancel out and you'd be left with negative 2v, which would give you the same answer. So there is more than one way of getting the answer. Okay, next one we want is the vector BG. So we want to travel from B to G, so we'll put that on our diagram. So there's the vector BG. So how do we get from B to G? Well, we can make it the sum of other vectors between its tail and its nose. So we can move along this vector and then move along that vector. Now, we're moving along B to A here. Now, moving along B to A, if you compare BA with this vector DE, you'll notice that they are parallel. They are the same length, and you're moving along each of them in the same direction, so they are equal vectors. So ED and BA are exactly the same. So therefore, to get from B to G, we move from B to A, which is the same as DE, so minus 2v. So BG is going to be minus 2v. So that's going to bring us to A, and then we are adding on AG, and we worked out AG up here. So we're then adding on minus 6t plus 4v. So tidy it up. So we've got minus 2v plus multiplied by minus gives us minus. So we're going to have minus 2v, we're going to have minus 6t, and then a plus multiplied by a plus, so we're going to plus 4v. So tidy up the v terms, minus 2v plus 4v is just going to give us 2v. And then we're left with minus 6t. And again, put brackets around the result. Okay, so it wasn't too bad. Now, part G then says, what can be deduced about the points D, B, and G? Well, it appears from the diagram that they lie on the same line. So it appears that they are collinear. Well, what we're going to do is prove that they're collinear, and we've done this before in a previous video. So how do you show that 3 points are collinear? Well, we're going to get the displacement vector joining D to B. In fact, we've already done that. We're going to get the displacement vector joining B to G, and we've already done that. Hopefully we'll be able to show that these two displacement vectors are parallel, and if they're parallel and B is the common point in each vector, well then the 3 points have to lie in the same straight line. So let's write down what DB is first. So DB we worked out in part D. So DB in part D was minus 6t plus 2v. Now, if you look at BG, which is just up here, it's 2v minus 6t, so it's exactly the same. So DB is exactly the same as BG. Another way of writing that would be to say DB is equal to 1 multiplied by BG. So in other words, we've shown that the two vectors are parallel, because remember, two vectors are parallel when you multiply one of them by a constant to get the other. So therefore, DB and BG are parallel. So DB and BG are parallel. B is the same point in each vector, so therefore the points D, B and G have to be collinear. So final bit, since DB and BG are parallel, and B is a common point, on each vector, then the points D, B and G are collinear. Okay, and that's it.